can ask you questions meanwhile. Those who are not sleeping, please lower your hand. Malcolm, for number 6, थोड़ा लेट होते ही हो आप PS के सेशन में देखे आंसर्स देखे आपके, बट थोड़ा लेट आते हैं ऐसा, ठीक है. Yeah, so the first model, introduction to signals and systems. So who will tell me the definition for signal and system? I want your definition. Okay, I don't want book wala definition. I want your definition. Okay, what is signal? Okay, Shruti.
Sir, signal means basically having some information.
Yeah. Good. So signal is simply defined as a set of information or data. Okay. Okay. She wants.
Like signals are basically used to transmit some data.
Okay. This is one of the application. Okay. This is one of the application. Good. Used. Then Mansi, you want to define something?
Yes, sir. A set of things working together, we can call it as a system, maybe.
Yeah, good. Yeah. So a set of physical components combined together to get some desired output is called a system. Like when you consider a lamp, bulb, it is a combination of filament, gas, glass, okay, no conducting material, non-conducting material. And when you combine all these things together, and when you give proper input, the output is in terms of light. So this is a system. Okay, this is a system. So signal is a set of information or data. Signal is defined as a set of information or data, and system is a set of physical components combined together to get some desired output. So this is the definition for signal and system. Okay, I forgot to record this session. Wait, let me record.
Recording in progress.
Nikhil sir, are you there? Because connection was not there on first floor. Okay. So students, if you don't know, our department is on first floor. Okay, where all the staffs sits over there in first floor staff room. Yeah. Whenever you come to college, and please do meet. कभी आप आए हो कभी तो मिलना है ऐसे, उसे ऑफलाइन मोड का तो वेट करेंगे. Yeah. So a signal is a set of information or data, whereas system a set of physical components combined together to get some data. Now system is like this, then how to design open loop, closed loop system, that is your task. This is a simple definition of system. Okay. Now introduction to signals. Now a signal is a function or one or more independent variable that carries some information. So this is Bocola definition to represent a physical phenomena. So we have ECG signal, we have EEG signals. You know what is ECG signal and EEG signal? Anyone of you? Okay, the signals
Sir,
we
I'm
use.
really sorry if I'm wrong, but ECG signal वो heart rate machine में जो होता है.
Yeah, good. Yeah, you're right. Who is this? I guess Swani, no?
Yeah, sir.
Yeah, okay. Good, right, good, better. Yeah. So ECG signal is for your the signals which we use for heart का all things. एंड EEG सिग्नल्स ब्रेन के लिए होते हैं, ऐसे बहुत सारे. तो मेडिकल बायोमेडिकल में बहुत सारे एप्लीकेशंस है, एंड नाउअडेज देयर इज अ बूम इन बायोमेडिकल. सो जस्ट थिंक अबाउट दिस पार्ट व्हेनेवर यू डिजाइन अ प्रोजेक्ट. वो वेब पेज डेवलपमेंट ये वो उससे बाहर आ जाओ. यू डिजाइन समथिंग डिफरेंट, यू हैव टू प्रूव योरसेल्फ. ओके, फ्यूचर में व्हेन यू गो अप्लाई फॉर अ जॉब, दैट टाइम यू हैव टू प्रूव योरसेल्फ. And your projects are very important. If you design a web page, सब लोग वही कर रहे हैं, मैं भी वही करती हूँ, वही करता हूँ, and then you may get 24 marks out of 25. So ऐसा नहीं चलेगा. Do something different. Do something different. So about signals, we have two types: continuous time signals and discrete time signals. So what is this continuous time signal and discrete time signal? I'll tell you. Like continuous time signal, the signal which is defined for each and every interval of time, which is continuous, just continuous throughout the domain, okay, is called as continuous signal. Or simply analog signals are continuous signals. Whereas discrete signals are those signals which are defined only for a particular interval of time, particular interval. And discrete के बाद digital आता है. Remember this. I'm telling you this thing. Discrete के बाद digital. Digital is different. Okay, digital is different. So first category of signal is, or the classification of signal is continuous time signals and discrete time signals. So if you want, I'll give you a graph. Okay, so this is continuous time signal. So this signal is defined for each and every interval of time. Okay, each and every interval of time. Like suppose if I think about 0, at 0 it has some amplitude. Okay, yeah, Deepak, continue.
सिग्नल में भी वो कंटिन्यूस में ही आएगा ना, वो तो मतलब डिफाइन रहता है 1-0 केस में हमेशा.
कौन सा?
तो 1 में या 0 पे हमेशा टाइम पे डिफाइन रहता ही है ना डिजिटल, तो कंटिन्यूस ही होगा ना.
नहीं नहीं, ऐसा कुछ नहीं. I'll tell you. Let me complete my task. I'll tell you that part. Okay. Yeah. So what is continuous signal? Continuous signal, like this time at this point. Suppose this is 1 second. 1 second को defined है. 1.1 second को defined है. 1.111 second को defined है. Each and every interval of time, सब जगह defined है ये सब. Okay. Or maybe t is equal to 100 पे भी defined है. It has some value. So all values are there. It's very difficult to store analog signal in PC or anywhere. It's difficult to store analog signal. Okay, because it is defined for each and every interval of time. Like t is equal to 1 second. Like t is equal to 1.1 time के लिए defined है. So it is very difficult. It requires a huge memory. Okay, so this is a continuous time signal, a signal that has a value for all points in time domain. This is your continuous signal. Okay, this is a continuous signal. Whereas discrete signal, and आज मैं आपको एक चीज बोलता हूँ, याद रखना. Discrete signal अपने यहाँ पे default step size is 1. जैसे हमने कल PS4 में पढ़ा था. That was very simple example. Step size means 0 के बाद क्या आता है? तो 0 के बाद 1 ही आता है. Next sample. Then 1 के बाद 2, 2 के बाद 3, 3 के बाद 4. Like this, discrete signal. बीच में कोई value नहीं होता है. And if you plot the graph of this discrete signal, the graph will be like this. Hope all of you understood this part. Continuous signal. Continuous signal is defined for all interval of time. Human speech, ECG signal, okay, EEG signal. All these are analog signals. Okay, analog signal, which is displayed graphically over here. So this is your analog signal or continuous time signal. Whereas the discrete time signal is like this. 0 के बाद 1, फिर कुछ amplitude, 1 के बाद 2, 2 के बाद 3, 3 के बाद 4, 4 के बाद 5, like this. So this is a discrete domain. This is called a discrete domain. And if you notice carefully, continuous domain signal is represented by x of t. X of t. I'll draw shape over here. Continuous signal is defined by x of t, like this. Okay, and the x-axis is t domain. X-axis is t domain. Whatever you have here is amplitude. Iska amplitude. Yeah, this is your continuous time signal. Now the next thing is discrete time signal. So for discrete time signal, I'll use clear all apart. This is discrete signal. The discrete signal is represented by x of n, and your x-axis is n. All please take care of this thing, because exam, whenever I ask you to draw a graph, that time you have to take care of this thing. Yeah, okay.
Sir, in discrete time signal, the signals will be always the multiple of integer number, right?
Yeah,
Like we cannot take 0 point something or 0.0 something.
नहीं वो हम फॉलो नहीं करते. 0.5 का अगर कोई पार्ट है तो उसको स्किप कर देते.
Okay.
That is one of the laws. Okay. So जैसे आपका व्हाट्सएप का इमेज है, व्हाट्सएप का इमेज जो आप सेंड करते हो, तो वहां पे जो जिसको रिसीव हो रहा है उसका साइज कम होता है ना. Why? Because the number of samples are taken out.
Okay.
Yeah. Okay. So this is the discrete signal.
Again, please talk more about the y-axis, x of t and x of n. Like, what exactly does it represent?
It's like a representation only. It's like a representation, simple representation for that particular signal. The discrete signal represented by x of n, and continuous signals are represented by x of t. Okay.
Yes, I understood that they are function of it, but if they are function of it, like what does those values represent? Like, why are we putting it on y-axis?
Whenever you draw a graph, okay, whenever you draw a graph, that point you require x-axis and y-axis, and you have to label it also. Agree? You agree with this?
Yes.
Okay. So suppose if I'm drawing a graph, like suppose this is a graph, you have y-axis, you have x-axis, okay, but what quantity you are taking on x-axis and y-axis, that you have to represent. So
Yes, sir.
so whenever you are drawing a graph, okay, in time domain, तो यहाँ पे क्या होता है? T, x-axis is t.
Okay, sir.
Amplitude, okay, y-axis you have amplitude, and representation for that particular graph is written over here. That is anything, and I'll write that is anything, that is x of t or f of t also you can write down. Sorry, small f of t. So this is the complete representation for any graph. What you have over here, I'll repeat again. What you have over here is time domain. Okay, we have amplitude and representation of that signal. Is this clear?
Here function is that amplitude and it is dependent on time, right?
No, function is
If we plot this graph, here the function will be amplitude and which will be dependent on the
no, better. Like when you have sine signal, what is sine signal? Sine.
0 to maximum.
Sine signal.
Yes, sir.
Sine.
Yeah,
So
right.
sine signal में कुछ amplitude होता है ना?
Yes.
But signal is not sine signal. Signal sine है, amplitude सब signal का होता है.
Yes.
Okay, so that is the different part. So f of t is the representation, like sine,
Okay.
cos, ramp, parabolic, step, जो आपने control system में पढ़ा है.
Yes. Right.
Okay. So that is the difference. F of t, x of t or f of t may vary. So that may take a curve of sine signal, that may take the curve of cosine signal. That may vary. Okay, amplitude is there for all. Understood?
Okay.
Amplitude is there for discrete signal also and continuous signal, but the representation is different.
Okay.
Is this clear now?
Yes,
sir.
understood.
I thought,
Okay. So we have discrete signal, we have continuous signal, and nowadays we all are dealing with only discrete, and that is the digital signals. जो भी आपके मोबाइल में आता है, okay, that is mobile, is digital signal. जो image है, okay, जो data है, सब कुछ digital domain में होता है, and that's why the processing is fast, and you are getting a clear things, like voice is also clear, आप अगर वो पुराना फोन देखेंगे जहाँ पे डायल करना होता है, वहाँ पे वॉइस का फ्लिकरिंग वगैरह सब कुछ होता है, बिकॉज दैट इज एनालॉग पार्ट. And when you are dealing with this, even if you check, if you have a Jio ka number and you are calling on Airtel wala number, the word that much clear. But when you call Jio to Jio, the system is same and the voice is more clear. Even you can Jio to Jio video call bhi kar sakte hain because 4G. So you can do that part also. Okay, so this is simple. All things are digital right now. So hope all of you understood this thing. Digital signal and discrete signal. And whenever you plot discrete signal, we'll be using that STEM command, STEM. Remember this, note it down in your notebook. I want a separate notebook for SS. I want a separate notebook. Yeah, Mansi.
Sir, digital signal is also known as discrete signal.
Yeah, I'll tell you the difference.
Okay.
What is the difference between digital and discrete signal is like discrete signal is defined for each and every amplitude. But digital signal, we have only two levels, 0 and 1. Okay, now I'll tell you, I'll clear your idea. Yeah, suppose if I draw a signal, you know step signal. What is step signal?
Yes, sir. 0, 1.
Okay, see, step signal is like this thing, U of t. We call this as U of, जो हमने control system में भी use किया है. Okay,
Yes,
which
sir.
has zero amplitude for negative time domain, and from 0 onwards it has 1 amplitude. Okay, ये amplitude कितना है? 1. And we call this signal as U of t. You call this signal as U of t. Okay, U of t, where the axis, the time domain axis is t, and we start with a 0 वाला part. जो मैं draw कर रहा हूँ वो visible है बेटा मानसी?
Yes, sir. Visible.
Yeah. So this is a standard unit step signal. Unit step signal जो हमने control system में पढ़ा है. You studied unit step signal. You have studied ramp signal. You studied parabolic signal. All these signals you have already studied. Okay. So these are few examples. Now this is completely analog signal. This is completely analog signal. How to convert this analog signal into digital discrete signal? By sampling this signal. तो ये U of t कंटिन्यूस डोमेन में है, सो डिस्क्रीट डोमेन में हमें इसको प्लॉट करना है. तो ये कैसे आएगा? इट विल बी लाइक दिस. आई विल चेंज द कलर नाउ. इट विल बी लाइक दिस. 0 पे 1. ओके, 0 पे 1, 1 पे 1, 2 पे 1, 3 पे 1, 4 पे 1, and so on. Okay, and so on. This will continue. This will continue till infinity. And this is also which signal? Unit step signal. And we represent this signal as U of n. We represent this signal as U of n. Representation. What is the amplitude over here? It's 1. Again, no change. What is the starting point of this signal? It's 0. Okay, and now what is the x-axis over here? Who will answer my question? X-axis क्या होगा?
So T.
Sir, N.
And
Yeah, good. It's n because it's a discrete signal. And now, students, both the signals are same. Both the signals are same. These two signals are same. Okay. One is in discrete domain and one is in continuous domain. Okay, the one which is on right hand side is continuous domain signal, and the one which is on left hand side is discrete domain signal. Hope all of you understood. Any doubts?
Yes, sir.
Okay, now Mansi, you were down. Okay, what is the difference between digital and ये? तो अभी हमने साइन सिग्नल लिया, साइन. If you take sine signal, okay, I'll draw a sine wave here. As a sine signal here. This is continuous or discrete? I'll not draw x-axis and y-axis right now.
Continuous.
Continue.
Continuous, okay. Now, when you try to convert this signal into discrete thing, okay, I'll use this part now. When you try to convert this signal into discrete thing, तो क्या होगा इसको ये continuous है, तो इसको आपको कट करना पड़ेगा टाइम डोमेन में, ठीक है? ये इस टाइम डोमेन पे आपको उसका वैल्यू लेना पड़ेगा, okay? वैल्यू लेना पड़ेगा, and when you draw, after this I'll clear everything. And now when you draw this signal, like your y-axis, your x-axis, and if you are drawing sine signal, discrete sine signal, तो आपको कैसे ड्रॉ करना पड़ेगा? यहाँ पे 0, okay, यहाँ पे 0, यहाँ पे some value, 1 पे some value. Please, मेरे पास अभी राइटिंग पैड है बट यूज नहीं कर रहा हूँ, बट आई विल ड्रॉ दिस. A rough idea. I'm not drawing it like that. I'm not using my standard signal. I'm drawing it because so that you can understand it. और यहाँ पे 0 है, यहाँ पे एक 0 है, यहाँ पे एक 0 है, ओके? यहाँ पे एक 0 है and यहाँ पे एक 0 है, इधर एक. Okay, now which signal is this?
Discrete.
Discrete, to be very specific, it is discrete sine signal.
Yes.
Okay,
Yes, sir.
if you join, if you take envelope of all these points, you will get a sine signal. Okay, you'll get sine signal. So this is discrete signal, discrete sine signal. And what is discrete sine? Digital sine signal? You have some levels, and amplitude भी 0 के बाद 1 आएगा, 1 के बाद 2 आएगा, 2 के बाद 3 आएगा, like that. In that range only. In between कुछ amplitude आता है, तो वो skip करना है.
Okay, sure.
Okay. Whereas, so now I'll give you answer, the best answer for this. कि discrete signal is discrete in time and continuous in amplitude. Amplitude हर एक value के लिए होता है, okay? Hope all of you understood it. Continuous signal is continuous in time and amplitude. Continuous signal is continuous in time and amplitude, whereas discrete signal is discrete in time and continuous in amplitude. Now the third part, digital, जो अपने को अभी study नहीं करना है, but I'll give you an idea about it. Digital signal is discrete in both. Time में भी discrete है और amplitude में भी discrete. Amplitude कौन सा भी नहीं चलेगा उसको क्या है amplitude कौन सा चाहिए? 0 के बाद 1, 1 के बाद 2, 2 के बाद 3, but 2.5, 1.5 नहीं होगा. या देखो, यस देखो,
एम्पलीट्यूड कंटिन्यूस होता है, वो एक्सप्लेन, मतलब जरा एक्सप्लेन करो ना.
अभी देखो ना, अभी यहाँ पे कैसा है, ये डिस्क्रीट सिग्नल में और थोड़ा बनाता हूँ. Okay, I'll draw more samples now here. I'll draw more samples. ये मैंने थोड़ा कम samples draw किए. I'll draw more samples. यहाँ पे मैं और samples draw कर रहा हूँ. Okay. And just imagine that हर एक sample का interval time domain पे 1 का है. Okay. It's a huge signal, but मैं draw कर रहा हूँ ऐसे. I'll try to draw. अभी यहाँ पे Okay, I guess उपकर ये आपका क्वेश्चन था ना? नहीं शायद दीपक.
No, sir. Deepak.
Yes, sir.
Yeah. So now here the signal is discrete. Okay. But amplitude कैसा है? Amplitude यहाँ पे amplitude I'll use blue color for this. I'll use blue color for this. Okay, so this is a discrete signal. This is a discrete signal where amplitude A1 है suppose and A2 है. This is 2. I'll use a curve. This is 2. This is 3. And this is 4. And यहाँ पे default step size कितना है? A1, 2. ये तो 1 के बाद 0 के बाद 1 है, 1 के बाद 2 है. On this side, on this side. So the default step size is of 1. So discrete in time. Discrete in time. But यहाँ पे क्या है? 1 और 2 के बीच में लाया है, कितने सैंपल्स कर रहे हैं? 1, यहाँ पे 1, 2, 3, 4. There are many samples.
Yes, sir.
Got it? Many samples. So that's why it is continuous in amplitude. दो लेवल में नहीं, दो लेवल में नहीं है, दो लेवल के बीच में और भी पार्ट्स है. Understood?
Yes, sir.
Yeah. So if I want a digital signal, a sine signal, तो मुझे क्या करना पड़ेगा? यहाँ से मुझे कुछ I'll draw here only with a different color. तो मुझे कुछ सैंपल्स लेने पड़ेंगे. एक 0 वाला सैंपल लेना पड़ेगा. यहाँ पे ये भी कुछ अलग है. ये वाला सैंपल मुझे स्किप करना पड़ेगा. ये वाले सैंपल्स डायरेक्टली मुझे ये सैंपल लेना पड़ेगा. उसके बाद मुझे 3 वाला सैंपल लेना पड़ेगा. उसके बाद और भी सपोज ये 3 वाला है. तो एम्पलीट्यूड फिक्स 0 के बाद 1, 1 के बाद 2, 2 के बाद 3 ऐसा जब आता है तो वी से दैट it is discrete in amplitude also. Now this idea is clear?
Okay, sir. मतलब ये डिस्क्रीट टाइम सिग्नल में से जरूरी नहीं है कि एम्पलीट्यूड कंटिन्यूस ही हो ऐसा. मतलब अभी आपने बोला ना एक
नहीं, अभी जो मैंने ड्रॉ किया वो डिजिटल है. डिजिटल डिजिटल में क्या है कि आपका स्टेप साइज, डिफॉल्ट स्टेप साइज एक्स एक्सिस पे और वाई एक्सिस पे 1 का ही होना चाहिए.
ओके सर, समझा.
ओके, 1 का ही, यानी 1 एक्स एक्सिस पे 0 के बाद 1 है तो वाई एक्सिस पे भी 0 के बाद 1 है. बीच में कोई और वैल्यूज नहीं आना चाहिए. 1.1, 1.2, 1.3 ऐसा नहीं आना चाहिए. ओके.
यस सर.
या फाइन. Malkan, you asked something. आपका मैसेज है कुछ तो. Can you please unmute yourself? Okay, Ananya. Meanwhile, you continue.
So basically in discrete, you're saying that on the y-axis, basically our amplitude that can be in decimal, right? The value.
Integer value. In digital.
So basically in digital, both my y-axis and x-axis value have to be in an interval of 1, but in discrete,
In discrete, it changes. Good.
In discrete, the time axis has to have an interval of 1, but the amplitude doesn't have to have that, right? Necessarily.
Yeah. So on amplitude, all the numbers are not integer values.
Okay.
It may take the fraction wala part also.
Okay, sir. And in continuous, everything can be in.
Everything is possible. 1.1, 1.111, like all these things.
All the okay.
Yeah. Good. So I'll clear this thing. This idea is clear now. And students, after lecture also, you please try to read the book because that understanding is very important. If you do, I'm very sorry. I forgot. CRs, please. Because मैं पढ़ाते जाता हूँ तो कुछ ना.
Yes sir.
I forgot. I thought that your lecture is from 10 to 12. It's almost 11:37. I'm extremely sorry for this. And even I gave you a break accordingly. So CR मुझे बोला करो कि जब ब्रेक का होगा ना तो मुझे टेक्स्ट किया करो बीच में अगर मैं भूल जाता हूँ.
All right.
I guess 11:30 को आपका लेक्चर एंड होता है ना?
Yes, sir.
Malkan, yeah, Malkan.
Sir, like I have a question, sir.
Wait, Malkan, wait.
Sure.
Sears, I'm extremely sorry. मैंने आपका 7 minutes ज़्यादा लिया. Yeah. So time हो गया ना अपना आज का?
Yes, sir.
Okay, we'll stop here, students. I'll not you have one more session after this, so we'll stop here. Those who wish to leave, they can leave. And Malkan,
Yes, sir.
others you can leave.
Okay.
Yes, Malkan.
Sir, over here, so you said that in digital signals, the clarity is more, like we are able to, if it's an audio signal, then we are able to, like, it's better than the continuous signal.
Yeah.
But in digital signal, we are like, it's not continuous, right? So then how can it be more clear? There can be lag.
When you have, suppose if you are having food, तो फूड थोड़ा टेस्ट करेंगे आप, तो अच्छा लगेगा ही वैसे, और वो क्वांटिटी ज्यादा होगा तो क्या होगा, वो मे बी अच्छा नहीं लगेगा. तो यहाँ पे कैसे है, एनालॉग सिग्नल जो हम यहाँ ड्रॉ कर रहे हैं, दैट इज ओनली सिंपल फॉर दिस इज ओनली फॉर अंडरस्टैंडिंग, जो ड्रॉ करना, बट एक्चुअली द सिग्नल इज वेरी ह्यूज, एनालॉग सिग्नल, व्हेन यू ड्रॉ इट एंड व्हेन यू टेक स्मॉल पार्ट ऑफ इट आल्सो, that is sufficient to define that signal.
Okay.
किसी ने सेंड किया आपको, वो भी आपको क्लियर दिखाई देता है, बट द मोमेंट यू टेक प्रिंट आउट ऑफ दैट तो ब्लर होता है. बट थ्रू व्हाट्सएप हमें क्या करना है, हमारा जैसे लाइक योर फैमिली मेंबर्स आर एंजॉयिंग समवेयर, video and image.